4.3. Identify the nature of emissions reaching the Earth from the Sun. So the flow of charged particles that make up solar wind is not a constant stream. It fluctuates with the changes in the Sun's magnetic field, which scientists monitor by studying the sunspots. So it dates back to the times of Galileo, when he was the first one to see sunspots with his telescope. The darkest spots on the Sun's brighter surface. So these are the black dots within the images of the Sun. We now know that the sunspots appear dark because they are regions that are cooler. They are associated with the regions where the Sun's magnetic field is stronger, and this causes more particles to be ejected in the solar wind. And the Sun's magnetic field undergoes cyclic changes over an 11-year period. So every 11 years there are more sunspots and more intensity in solar wind, sometimes to the extent that it can affect our power supplies and communication supplies on Earth. Even though it's a great distance away, it still affects Earth. So when the sunspot activity peaks, our magnetic field can be overwhelmed by the solar wind. So charged particles penetrate the field and are sent into spiraling paths towards the Earth's poles. So intense pulses of electromagnetic radiation at radio frequencies can result, which can cause static jamming of communications, especially satellites, telephone links, which use radio and microwaves. So extreme pulses can cause surge in electrical power lines and damage to electronic equipment. You may have not known that before this physics topic, and the early emissions that you would have seen in relevance to emissions from the Sun would be looking at the Aurora Borealis and the Aurora Australis, which is both at the North and South Poles, and they are sometimes described as the Northern and Southern Lights, and that there is a clear indication that the Sun's charged particles reach Earth. So looking at the right hand side, what does those charged particles do to our magnetic field? So it influences and interacts with our magnetic field to penetrate through the magnetic field. So this alters Earth's magnetic field slightly because of these charged particles. Now these northern and southern lights have interacted with the elements in the atmosphere's layers, and the reasons are for the different colours is the different composition in that atmosphere at that time and elements occurring. So the key things here to understand is knowing that charged particles reach Earth, and this is caused by solar wind, that the sunspots are the strongest magnetic field dispersion places on the Sun, and these are the black regions on an image of a sun. The sunspots undergo a cyclic change over 11-year cycle, and that these charged particles have an effect on the Earth's surface.